Hi, can you help me with this problem?
Yeah, sure. I'll give it a try. So what do you want to do with that?
Well, it says we have to simplify it in a way that the variables have a power of 1.
Oh, so it just wants us to expand it, right?
Sure.
Okay, well for that we just need to remember some of our rules, but I don't really remember some of them, do you?
I don't because, now that I think of it, where are we going to use this in real life and where does it matter?
I mean, like, in some of my classes, I've used it if I wanted to take a derivative. It would be really complicated to take it like this, but if we could expand it out, sometimes it makes it simpler.
Okay, I don't see a point in memorizing something I'm not going to use, but I remember this. So if we have the log of a plus b, it simplifies to log of a plus log of b.
All right, let's test this out to make sure it's right. So
All right.
I know that the log of 1 is just 0, so why don't we plug in 1 for a and b?
Okay, let's try that.
So we would have the log of 1 plus 1, and that's equal to the log of 1 plus the log of 1. Well, this is just the log of 2, right?
Yes. Oh, no, wait.
Oh, because these
Log
would
of-
both,
yeah.
those would both be 0, right?
Log of 1
so
would
we
be
have
0.
0 plus 0.
But that
But
doesn't
that's
make
not
sense.
right, because this is a number. It's not 0.
Yeah, that doesn't make sense. Let's see. Since the logs are basically inverses of exponents, let's think of it as a way if we're multiplying exponents. Or let's think about multiplying 1,000 with 10,000. Usually if I do that, I just count the number of zeros. There's 3 here and 4 here. I would add them together, so it would have 7 zeros, and I would just put a 1 in front.
Okay, so when I do it, I normally use scientific notation.
Can I see that?
Yeah, so we would just want to convert this, so we'd have 1, 2, 3. So this one would be 1 times 10 to the third. And this would be 1, 2, 3, 4. And that would be 1 times 10 to the fourth. So we'd have 1 times 1, so that's just our 1 there. And I know since we're multiplying exponents that have the same base.
Mm-hmm.
Oh, wait, that's not right. Okay.
Yeah, they have the same base.
Well, yeah, I didn't say it right. Okay, so we'll just do it from here. So I know that 1 times 1 is just 1. And then since we're multiplying two numbers that have the same base, we would just add their exponents.
Oh,
So we would
I
have
remember
times
that.
10 to the 7th, because 3 plus 4 is 7.
Oh, okay. So in this case, we're using multiplication and we're adding the exponents.
Mhm.
So let's try that here.
Oh,
What
so
if we
change
did
that. Yeah,
multiplication?
maybe that
But
would
I
work.
just have one question. How come we have a natural log problem, ln, but this formula says log? Is that
Oh,
going to help us?
Well, so ln is just log base e. So these rules hold for anything. So we could have log base e, which is our ln, or we could have log base 10 in this case,
yeah,
log
log
base
base 10.
5, or log base 2. The list goes on. We could have anything we want.
Oh, okay. Let's go ahead and try that out.
Okay.
So-
All right, so let's still plug in 1 for a and b.
okay.
So we'll have log of 1 times 1, which is the log of 1. And then we'll have the log of 1 plus the log of 1. I think this should work, right? Because this would be 0. And these would both be 0.
Oh, perfect.
Yeah, so
Wow.
this is actually our product rule, I think.
Mm-hmm.
Yeah.
What about the other rules?
Oh, so I remember those. So we have our quotient rule that says the log of a over b is the log of a minus the log of b.
And then it's log, because again, it doesn't matter if we're using ln.
Yeah, we could have done ln of a over b.
Nice.
And then we have our power rule also, so that just says that the log of a to the n is just n times the log of a.
Wow, okay.
Mhm.
Now that I understand it a bit more, let me go ahead and give it a shot.
Okay.
So, I noticed that these two are being divided, so I
Yeah,
could
so
use
yeah,
a
let's just use our
division.
quotient rule.
Yeah, so we're going to have ln of a cubed minus the bottom, which is ln of 3b squared. Okay, so now I
Well,
noticed that these two,
Yeah, so we're multiplying 3 and b squared, so we could just use our product rule that we came up with.
cool. So I'm going to expand that. So we have ln of a cubed minus ln of 3. And then now since these two are multiplied, I could just say plus ln of b squared.
So when I did this problem earlier, I actually got a different answer than you.
Really?
Yeah, so I had a negative right here. So when I do these problems, I like to use lots of parentheses.
Oh,
So
okay.
I'm going to add some here since this whole thing is in the denominator.
Oh, okay.
And so now when we expand it out, these would be here.
Okay,
And so this should have distributed, right?
yeah, so that should have just been ln of a cubed minus, if I'm distributing the negative, I'm going to have ln of 3 minus ln of b squared.
Okay, I think that's what I got.
Nice. Okay, so now it looks like the last step to do is the power rule. So I'm just going to take these and bring it to the front, the powers. So I'm going to have 3 ln of a minus ln of 3 minus 2 ln of b.
Awesome.
Wow, now that I look at it, it looks a lot more cleaner. Like, imagine if I have to take the derivative of that first one.
Oh wow, that would be horrible. But like now that we have this, it'd be so much easier.
Yeah, because for that one, I would have had to use chain rules and quotient rules. For this one, I just noticed that they're just ln's of numbers. I could take that 3 out. It would be a lot more cleaner.
Yeah, and then what if we wanted to like solve for a?
Yeah.
That would be so much quicker.
Yeah. So now I see like where it would make my life a lot easier, especially if I'm taking calculus.
Yeah.